Hi, my name is Colin Lynch, your friendly neighbourhood UCS guru. The subject of this post will be boot from SAN configuration and all the bits in between. Probably one of the most common questions I get in the Ask the Guru section on the blog site is around boot from SAN, either configuration or troubleshooting, whether it be for the UCS elements, the SAN switch elements, or the array elements. So I thought it would be probably about time that I posted an end-to-end video on how to set all the UCS bits up, all the Nexus bits up, all the MDS or MDS bits up, and the array bits. So that's the goal of this post. So we're going to have roughly 3 sections. So the first section will focus on the UCS configuration, the second section on the SAN switch configuration, and the third section will cover the array configuration. So this is the setup I've got in the Cisco UCS test lab here. So as you can see, I've got 2 chassis, 2 6120 fabric interconnects. The fabric interconnects have a native fiber channel connection to their respective Cisco MDS switches, which are providing the SAN fabric elements. We've got a few arrays on this environment, a couple of EMC arrays and a NetApp array. For the purpose of this post, we'll use the NetApp array to present the storage to our ESX host. I'm not sure how long this video will run. It'll probably go an hour or so. So my advice, grab yourself a scotch or whatever your tipple of choice is, sit back and relax and let it caress over you, and hopefully you'll find something of interest in it somewhere. It's not meant to be a deep dive in any of these particular topics, but basically the basic configuration to get boot from SAN working and a few checks along the way. Okay, so let's dive straight in then and create the UCS elements of the configuration. So you can see there that I've got 4 service profiles already, ESX 1 through 4, and a bare metal 2008 R2. So what we're going to do is go ahead and create an ESX 05. Numerous ways of doing that. My personal preference is to use an updating service profile template, in which case you would just right click your template and do create service profile from template, give it a name, ESX 05, and we just want the one. Obviously we could have several, so we just have the one, and that would immediately give me a new ESX service profile. Obviously that's no fun really. It's very efficient, but I guess not much fun if you want to see the process. So let me just delete that fella there. Okay. Another option, of course, would be just to find a service profile with the same rough settings that we would want, i.e. a couple of HBAs and some VNICs, and I could just right click and create a clone of it. And I could give that a name, ESX 05, and stick it in my organization, and that would immediately pop in ESX 05 with obviously all unique identities. So you can see there we've got a couple of worldwide port names. We'll be talking a bit more about them later, and the same VNICs as the one I cloned it from, ESX 04 in this case. But let's start from the very beginning, as they say in The Sound of Music, and I shall delete that fella, and we'll just create one pretty quickly manually. So I've already got all my pool setups, my UID pools, my MAC pools, my worldwide port name pools, etc. So this should be a fairly quick process. So we're all expert, so let's create a service profile expert. I'm going to give this a name, ESX 05. My UUID pool is for UCS demo, got plenty still in there. Okay, again we're all experts here, so let's do an expert here. The reason I tend to do expert rather than simple is that if you do simple, it doesn't generally, or it doesn't give you the option to assign your pools to your actual devices. So you have to retrospectively go and put them, associate them. But if you do expert, you can actually assign them to the pools at the same time. So what am I doing here? VNix. So it's just, this is an ESX server, so let's just give it a management in Fabric A. Because this is a demo environment, I'm generally just using this VLAN 107 here, and I'll give it the MAC address of my UCS demo pool. Pretty much leave everything as is. I'll just change that to VMware. Okay, so that's management A. Let's create now a management B. Go to Fabric B. Again, the same VLANs. Same MAC pools. I generally don't use a different pool for different fabrics for MAC addresses. Some people do, and again, if it's a requirement that would help you troubleshoot, feel free. Use your demo pool, adapter policy. Again, just a note here. Again, I've seen some people that will create just one management NIC and actually rely on the fabric failover to actually protect that NIC, but we all know with vSphere actually will give you a false error, if you like, if it doesn't think you have a redundant uplinks for your management. You can suppress it, but I find it's easier just to appease it, give it 2 NICs, and let vSphere handle the failover. Okay, so I think we're done there. So I'll add in a vMotion NIC. And this is where I would generally just rely on fabric failover. The reason I do that is that if you have a single NIC mapped to a single fabric, you can actually isolate all your vMotion traffic within the same fabric internet, rather than it having to be layer switched upstream if you had a fabric A and a fabric B providing a dual uplink. Inter-fabric vMotion traffic would have to be layer 2 switched upstream. So again, it's just a nice way of keeping it within the fabric. And VMware, my UCS demo pool. Let's just add a couple of distributed virtual switch A. And we'll give a distributed virtual switch B. So this will either be a distributed switch within VMware, or what I tend to use more often is the Nexus 1000V. And we'll give that a MAC address. Adapter policy will go on VMware. Okay, so that looks pretty much like a standard ESX server, apart from that I have put my DVSB on A. Let me just quickly change that. See, always worth checking. Okay. Next. So storage, we're going to do a full boot from SAN here. My worldwide node name, I have a worldwide node name pool, UCS demo. In fact, that's, again, you'll see here you don't get the option of associating our virtual HBAs with a worldwide port name pool. So again, why I tend to do expert there. So let's add in an FC0 and map that to our Fabric A. Now that's Fabric A. Now in worldwide port names and virtual HBAs, I certainly do split them out into a different pool. It just makes troubleshooting a hell of a lot easier. So I'll generally have a double A in my worldwide port names for Fabric A, and a double B in my worldwide port names for Fabric B. Again, it just makes life so much easier that if you start seeing B's on the A side, you know someone's probably got a cable round the wrong way or something like that. Okay, so that's FC0 to Fabric A, default vSAN. Because this is a lab environment, I'm only using a default vSAN. Again, in a production environment, I'd certainly create a vSAN ID and make it different for each fabric. Adapter policy, we'll create VMware. Okay, let's add in a FC1 and map that to Fabric B. That's my worldwide port name pool for Fabric B. Fabric B there. Again, default vSAN. Again, it's just my lab environment. Adapter policy, VMware. Okay. Just double check that. Okay. So zoning, we're not using our Fabric Index as a fiber channel switch, so we can just crack on with that. Placement policy, I generally put, because this is a boot from SAN, I'll generally move our VHBAs to the top of the list. Okay. Okay, so this will be quite important. Select a boot policy to use. We're going to use a boot from SAN policy. I've already created a boot from SAN policy called boot from NetApp. I've got a few arrays in the environment here, so we'll use the NetApp today. When we get into the array side, we'll cover that detail. But you can see here, so I've got a CD as the first boot. So I have on occasions found that sometimes you need to put the CD below the SAN. VMware I find is fine with it. I think I have had issues with Windows needing the SAN to be the first boot device if you're doing a boot from SAN. So you can see here I've got a primary SAN boot of my FC0 and my secondary of FC1. Again, because this is a lab environment, I've only got two front-end ports of my NetApp filers connected, one to Fabric A and one to Fabric B. Now they're the worldwide port names of the NetApp controllers. So in SAN terms, they're referred to as the targets, and the worldwide port names of our UCS blades are referred to as initiators. And again, when we get onto the SAN config, that will make a little bit more sense. Okay, so we can pretty much go all the way through defaults here. Maintenance policy, I generally have the default change to user acknowledge, always a best practice there. Server assignment, I'm not sure if I have any spare blades at the moment. Let's see if we have. Oh yes, I do have one. So we'll assign it to our chassis 1 slot 4. And not worried about changing any BIOS settings at this stage. So we can just finish that and let that associate itself. Okay, so that should be our policy created. And indeed it is, ESX05. Again, because this is a shared environment, I generally just like to put a nice little user label on who's using the environment. So ESX05, I'll put a little user label on, letting everyone know that I am using it. Okay, so that seems to be associating okay now. That's just going through all its settings. Again, if I wanted to KVM that and actually have a look at it. We should see it going through its boot order. One thing I do actually probably want to change here is whenever you're setting up boot from SAN, it's a good idea to turn off quiet boot through the BIOS, just so you can view the actually what the server's boot process is, rather than looking at that lovely Cisco banner. So in order to turn off quiet boot, let me just go into my policies, BIOS policies, and I think I do have one that says no quiet boot. And again, if you want to see what that actually looks like, it's just under my policies down here. BIOS policies, so no quiet boot, has got quiet boot disabled. So again, if you wanted to create that, it would just be a right click, create BIOS policy, call it whatever you want, and turn off quiet boot. Okay. Something I tend to do just as a standard nowadays, really. Most of the installations I do, I boot from SAN, so it's always good to see what the servers are actually doing. Okay, so if now I KVM back into that ESX host, so this host should be going through its boot process at the moment, which it is. And you can see, because we've got quiet boot turned off, we're actually seeing some information there. Okay, so this is it trying to boot off the SAN at the moment. So that's saying the Cisco VIC FC. So it's initially trying to boot off the FC0. Now it's actually trying to log into the fabric, the switched fabric, in this case a pair of MDS switches. But because those switches have not been configured yet, it won't discover any targets. So this will just time out at the moment. But what it would have done by now is actually the blade would have logged in to the fabric interconnects. As we know, the fabric interconnects in effect pretend to be a fiber channel switched to the blades. They run in what's called NPV mode, which is N port virtualizer mode. So we can actually see that. So let me just get rid of that window there, which isn't going to do anything at the moment. So if I fire up a console session to my fabric interconnect, which is A, and if I can actually do a show floggy, show NPV floggy table, I can actually see that our worldwide port name is in the floggy table of the fabric interconnect, and has been allocated a virtual fiber channel interface of 2285. If I wanted to confirm that, I can see that it ends in 00 or AA009F. Remember I said about using an A or a double A on the fabric A side, so you can immediately see if there's any issues there. So we can confirm that. So if I actually have a look at our service profile and go into my VIF paths, I can see that virtual circuit 2285 is indeed our FC0 and is up, and FC0 does in fact have the worldwide port name of AA009F, which we can see there, AA009F. Okay, so I know that everything's working as it should at the moment. Okay, so the next thing we'll need to do is actually create our aliases and zones on our fiber channel switches. So in preparation for that, what I would generally do here is cut and paste our worldwide port names of our initiators. So let me fire up a notepad session. So FC0 and FC1. Okay, so AA and BB. And what I would also do at this stage is grab the worldwide port names of the targets. So these are the ports on the filers, or the NetApp filers, or the storage array in this case, that we want our blades to log in and boot from. So if I go into our boot order, I can actually see there. So our FC0 will be logging into this target. In fact, to actually copy and paste that, I'm going to have to actually do it from the policy. So boot policy, boot from NetApp, and I'll be able to do it here. So that'll be my target for FC0. And that will be my target for FC1. Now, if you don't know your targets, there's a couple of ways of finding out. Either ask the SAN administrator, he'll be able to inform you of that, or if you know the ports on the SAN switches that the storage array is connected to, you can actually get them off the SAN switches. If you think of worldwide port names as a MAC address, if you like, a MAC address for a fibre channel device, so they're fairly easy to pull out of a switch once you're on the switch. Okay, so the next stage will be to actually log into our two switches, which I will just do now. Okay, so let's just fire up a console window to both of our fabric switches. Just minimize these out of the way. Okay, so I've got two Cisco MDS switches, one fabric A and one fabric B. So let's bring up fabric A first. Now fabric B. These MDF switches are also supporting AV block, hence the names there. Okay. So again, just my preference, I tend to have them open both fabrics simultaneously when I'm doing the config, because I'll generally do the config on both fabrics simultaneously. But just to keep things nice and easy, we'll do one at a time here, just so we cover all the concepts. Okay, so you'll remember from our last session when we was doing the UCS configuration, we verified that our worldwide port names were in the NPV floggy table. You'll remember that from the point of the HBAs, the fabric interconnects are a SAN switch, a fibre channel switch, running in what's called proxy F-port mode. However, from the perspective of the SAN, the MDS switches in this case, the fabric internets are actually a host, hence why they're in NPV mode, N-port virtualizer mode. So basically the fabric internets are proxying. So the HBAs or the virtual HBAs from our UCS will be doing a fabric logging or floggy into our NPV fabric interconnects, which we verified by doing that show NPV floggy table, and then our fabric internets will in turn do a floggy into the SAN switches. So we should see our worldwide port names from our service profiles in our MDS switches. So we can verify that by doing a show floggy database. And from memory, I think it was AA009F, and there it is there. Again, if you've got some very large floggy databases, you can pull out just the lines you're interested in by doing a show floggy database and then just doing a pipe with an include then whatever information you're interested in. So AA009F, we'll just pull out the line that we're interested in, so I can tell that my server is actually connected downstream in the MDS from the FC118 port on the MDS. So I can just verify that is indeed our worldwide port name of our FC0, AA009F, and indeed it is. So we should have the same on our fabric B side, albeit with BBs rather than AAs. So show floggy database, if I can spell, database, include BB009F, and there it is. Okay, so you'll see that the only difference between these worldwide port names is actually the fabric they're on, i.e. AA in this case and BB in this case. You'll see that the last 4 hex digits, 009F, are the same in both cases. So that's done on purpose because it makes life very easy. So I can immediately know that that's my fabric A, that's my fabric B, and I immediately know that 009F in both instances relates to ESX05. The way you can ensure that your addresses, because bearing in mind that they're from 2 different pools, that's from my fabric A pool and that's from my fabric B pool, but they're being dished out by UCS Manager in the same order, hence why I've always got the same last digits, and you can ensure that by just making sure that all your pools in your WWPN pools are in multiples of 16, and then they should all, as long as they're being dished out in even numbers, which you would normally do on a host, you'll always get that same last few digits, which makes life very interesting, a lot easier. Okay, so first thing we need to do is we need to create our fiber channel aliases, our FC aliases. As you can see, these addresses are quite cumbersome, 64-bit long hexadecimal digits. We don't really want to be specifying them any more than we have to. So we'll create an alias. So you can always have a look at what aliases are currently active on the switch by doing a show FC alias, and there you go, you can see some examples there. So you've got the alias names and then the port worldwide names associated. I know for a fact, for example, there's our target because we're already using that boot from SAN policy, so NetApp SAN A, and we can just verify that is our target. 0B9B 0A, it is indeed. So we only have to create the aliases for our initiators. As we mentioned, that you've always got an initiator to target conversation in the SAN world. Okay, so create our aliases. These are Cisco MDS switches, as I've mentioned, so they run either SANOS or NXOS, depending on what version of code you've got. So we'll do a compt and the command is fc alias name, and I always use the service profile names for our aliases. This is why it's nice for either the person who's already set up the MDS, who already set up the UCS, to also do the fabric configuration, because he'll know to use a nice standard naming convention throughout. Sometimes, though it's not, you might have the array administrator doing the SAN configuration, or it may even be a SAN admin in their own right, in which case let them know what your worldwide port names are and what your service profile names are, because it just makes sense if you can maintain a nice end-to-end naming convention all the way through. At the end of this video, I'll show you a nice little spreadsheet that I normally email to the SAN people if it's not me doing the SAN configuration. Sorry, every time I say the word SAN, people always get that image of Star Wars, them shaking their spears up and down. Okay, so we've got FC alias name, ESX05, and what HBA we're interested in, FC0, and what vSAN we're in. So again, this is just all default vSAN1, and our alias is created, and we can prove that by doing a trusty do. For those of you who used to work with a Catalyst before, or Nexus, used to have to do the word do command, so you can do a show at any point. With Nexus now you don't. So do show FC alias, and we should see as our last alias the one we created. Okay. So there's our alias. So what we need to do now is add our worldwide port name to it. So member port worldwide name, and we can either cut and paste this out of the Floggy database directly, or from the cut and paste we took earlier. So straight in there. Okay. So that's done. So again, normally I'll do FC1 on fabric B side, but we'll just finish one fabric in its entirety first. Okay, so the next thing we need to do is create our zones. So a zone, what's the best way to explain a zone? So if you imagine in an Ethernet switched environment, everything can talk to everything natively. It's a default open environment. It's the opposite on a SAN switch. Nothing can talk to anything without it explicitly being told to. It's a closed environment by default. So a zone will actually specify what can talk to what. Now you can add ports to zones rather than worldwide port names, which is called hard zoning, but that's quite rigid, and obviously if a host moves to a different port, you're going to have to re-zone the switch again. So what's more common and more flexible is what's called soft zoning, where you allocate the worldwide port names to a zone. So we'd put at least a worldwide port name of our initiator and a worldwide port name of our target or multiple targets. It's always a best practice to have a single initiator in a zone. It's also a best practice to have a single initiator, single target. But if you can imagine, you've normally got numerous targets in a fabric. So I generally just do a single initiator and then multiple targets in my zone. Okay, so to create our zones, we can actually do them from this config prompt. And it is zone name, and we'll call this ESX05 to NetApp. Again, make your zones descriptive as to what they're allowing to have that conversation. So this is allowing ESX05 to talk to our NetApp, and again, what vSAN we're on. Okay, so now I have to put in our two aliases, one for our initiator, one for our target. And again, in a production environment, you'd probably have multiple targets, at least two. But just for function, we can certainly get away with one. So we want member fc alias ESX05 underscore fc0. Okay, and we also have the alias for our target, and I know that's already in there. So remember fc alias, and that was called NetApp underscore SAN A. Okay, so we've created our zone there, and we can do that by doing a show zone. We can just confirm that. Do show zone. And again, it will normally be the end one. Okay. So there's our zone, ESX05 to NetApp, and you can see that we've got our two aliases in there. And again, we can just confirm those worldwide port names. So our AA009F, AA009F, and then our target should be 890B 9B0A, which it is. Okay, so with that zone, we're allowing that host to log into that NetApp port, which is exactly what we want. Okay, so next thing we need to do is we need to add this zone we've created to a zone set, because obviously if we're using a single initiator zone, we're going to have more than one initiator, so we're going to have lots of zones. So we need to allocate that zone to a zone set. Now you can only have one active zone set on a fabric at any one time. So to view what your active zone set is, do show, I think it's zone set active. And you can actually see the name of our active zone set is this. Zone set name is ZVBlock Fabric 1. So I'm going to copy that for future use. And so now we're going to add our zones to this zone set. So the way we do that is zone set name, and then our paste, and then our vSAN number, vSAN1, and then we need to add our zone in. So member, and it was ESX05 to NetApp. Okay, so our zone is now in our zone set. So the last thing we need to do is actually activate that zone set. Basically just reread that file in effect. So again, non-disruptive to do, and the command is zone set activate. Oh, might not be able to do it from in here. I have to come out. Zone set activate name, and again our vsan1, and I'll just reread that file. And so now if we have a look at our active zone set, show zone set active. Show zone set active. We should see our zone that we've just added in and our two worldwide port names, and you can see we've got an asterisk next to both of those, which means that they're actually active in the fabric. You'll see there we've got some FCIDs associated. Think of FCID as if you're thinking of the worldwide port name as the MAC address, think of the FCID as the IP address. It's dynamically assigned by the fabric switches, and that's the routable address within the fabric. The worldwide port name isn't routable. And again, that will show up in a show floggy database as well. There you go. So the FCIDs are all there. Okay, so now we've done fabric A. Let's do fabric B. So again, exactly the same. And if I'd thought about it, I could have copied a lot of these commands, but we'll do them afresh. So we want to do our alias first. So conft fc alias name ESX05, but this time it's FC1. Oh, I need my vSAN ID on the end there. And then member port worldwide name, and now it's this address here, BB009F. Okay, and I know our target has already got its alias for NetApp SAN B, so now we'll just create our zone. So name ESX05 to NetApp vSAN1, and our two FC aliases ESX05 underscore FC1 and FC alias was NetApp underscore SAN B. Okay. So show so let's have a look at what our active zone set is on this side, and this is called fabric 2. So Z vblock fabric 2. So we just need to add in that zone to this zone set. So zone set name, paste that in, vSAN1, and then member, and it was ESX05 to NetApp. Okay, so last but not least, just to activate the zone set, zone set active name, paste that in, vSAN1, it should reread that file, and then show Zone set active. I have to stick a do in front of that. Control A, do, and right at the end should be our I'll miss it. Oh, there it goes. There it is there. Okay, so again, asterisks, which is always a good sign. It means they're actually visible in the fabric. Okay, and that is our SAN switch done. So what we've now is we've allowed our initiator to talk through to our target. So the Fabric Interconnect or the virtual HBA will do its floggy to the Fabric Interconnect in NPV mode. The Fabric Interconnect will then do an ongoing floggy into the SAN switches, and then the virtual HBA will then do a port login, a ploggy into actually the target array. So then we should see the initiator register with the array. Okay, which will be our next task. Okay, so that's just okay. So the SANs are all configured, both fabrics, so we've got a dual path between our initiators and targets. You notice that we've been doing all the configuration via the CLI. There are GUIs available for this. Fabric Manager, or as it's now been replaced with DCNM, Data Center Network Manager for SAN, but I still prefer CLI, but there are tools available, and they're probably more ideal for for larger fabrics. But whatever floats your boat. Okay, so as mentioned, last thing we need to do is configure our array, which in this case is a NetApp filer. But the concepts are the same whether you're working on an EMC array or a NetApp array. You've all got to do the same basic things. So we want to go into our filer view. So first thing I need to do is register my initiators. So I need to go into my LUNs, initiator groups or iGroups. Again, if you're using Unisphere on an EMC array, these would be known as host groups. Okay, so I want to add an initiator group, and again, we're not here to make life difficult for ourselves, so we'll call these nice and simple names. ESX05 will be good. So Fiber Channel Protocol, and we are Solaris. We are VMware. Okay, so initiators by default it will just pre-populate that with all the worldwide port names you can see. So we'll just take those out and add the two we're interested in, which is our FC0 and our FC1. So we can talk to both HBAs across both fabrics. So we've got redundancy if a fabric or a switch or a NetApp controller was to fail, but while they're both up and running, we've got load balancing across the two. So that all looks okay. So that is our initiator group created. Next thing we need to do is actually create the storage. So in NetApp terms, we've got our aggregate, which is our collection of disks. So if you want to have a look at what aggregates we've got, so there's the one I've created for our UCS demo environment, which is a 2 terabyte aggregate with just over a terabyte free on it. And again, this is a shared environment, so I generally make it quite clear that I'm using it. Please do not wipe. So we'll certainly use that aggregate. So things we need to create, we need to now create our volume in that aggregate. So I shall now add a volume, and again it will be nice and descriptive in what we call it. We'll call it ESX05 boot. Obviously after this, if this was a VMware cluster, we would create an additional volume and LUN for our shared data store that all our hosts would be able to access. But obviously for our boot LUN, we want that for the sole use of the host. We certainly don't want another host accessing another host boot LUN where it could overwrite it and cause all sorts of grief. So we'll make this an exclusive to this host. Again, defaults are fine there. What aggregate do we want it on? Well, as we've already seen, we want it on the UCS do not wipe aggregate. And let's give it a usable size of 10 gig. That's more than enough for an ESX55 host. Again, it's just a test host, so I'm not really worried about reserving space for snapshots. So we'll just make that 10 gig and commit that. Okay, so we've created our volume now. So again, we can view that volume. I just have to do a refresh. Oh no, there it is. ESX05 boot. So 10 gig, and all 10 gig is currently available, as we'd expect. So next thing we need to do is create our LUN, and we can do our add a LUN, and so it was our volume ESX05, and we'll call it LUN 0, and again it's VMware. Again, being a boot LUN, it needs to be LUN 0, and ESX05. Give it a nice description, and we'll make it 10 gig. Don't need to reserve any space. Okay, no search volume because we called it ESX05 boot. Okay. So that all should go through okay. Indeed it has. So now we need to manage that LUN because we haven't allocated that LUN to a host yet. And so we need to go and find that LUN, which is ESX05 boot. Okay, there it is, ESX05 boot. And you'll see here it's got no maps. So if we just map that to the I group that we've created, add groups to map. And we called it ESX05. There we go. Add, and this is the important bit, LUN ID 0. So again, being a boot LUN, it has to appear to that host as LUN ID 0. Okay, so we have a successful LUN created. So again, let's just confirm that. So ESX05 again, I'm sure it's staring me in the face. There we go. ESX05 boot LUN is online and mapped to ESX05 as LUN 0. Okay, so that is our NetApp elements completed. So last thing we need to do is now go to our ESX server and boot off the VMware 5.5 ISO and install the operating system, and then ensure that our server boots. So that will be the next thing we shall do. Okay, so the last thing we need to do is go into our ESX05 KVM. Okay, and we need to mount some virtual media. Okay, and let's map our CD to need to add an image, and I've put it in VMware 5.5, and we have the OEM Cisco installer will be this one. Map that. Okay. And let's reset that server. Okay, so we've got quiet boot off, so we should see the boot process now. And if we remember last time, I think as soon as it initialized the HBAs, it just hung, because obviously it wasn't receiving any fabric logging information. But now we've configured the SAN and told that these HBAs can talk to their target ports. It should now see the target. I may just speed this up a little bit for you guys at home. Okay, so there's our FC0, so it now should log in and it has seen our target on Fabric A. And now it should be Fabric B, and Fabric B are FC1, and we've seen our target on FC1, so that's all good. So now it should be booting off our ESX55 CD. Probably see it counting up the read bytes on our virtual CD. Yep, so certainly something's happening there. Okay. So the next moment of truth is whether it will actually see our LUN when it does its bus scan very shortly. Okay, wouldn't it be nice if it loaded that fast in the real world? Okay, so we're just finishing our initial boot. Okay, so at the moment, okay, so at the moment of truth, will we see our LUN? Scanning. And there we are, 10 gig NetApp LUN. So we shall install on that. Okay, and I'll probably speed this process up a little bit and fast forward to the end of the installation, and then we'll watch the server boot. Okay, so we are successfully installed. So let's do a enter to reboot. Okay, so just verify with no virtual media mapped. So again, with the quiet boot turned off, we can actually view the boot process. So it'll be similar to last time, where we should see both our virtual HBAs initialize, log into the fabric, do a fabric scan and report back the worldwide port numbers of the targets that they can see. So this should be our FC0 and whammy, there's our first NetApp target. And now FC1, there's our second NetApp target. So you can see our LUN that we've created over both fabrics. And now it should boot ESX. It's looking good. Obviously bear in mind this is the first time it's booting, so it's not going to have any IP information, but that all looks good. And there we have our SAN booted ESXi server. So I won't bore you of just filling in the IP information, etc. So again, just a nice way of confirming that on our service profile. We can actually go to our server and have a look at the boot order, both of our configured boot order and our actual boot order. And we can see that it's actually booted off our NetApp LUNs there. Okay, and lastly, earlier in the video, I mentioned that I'll show you a quick spreadsheet that I tend to create for each of the hosts that I create within UCS service profiles, and I'll generally email those to the SAN admin, the array admin, and possibly the ESX admin if obviously it's different people, and generally I'd attach those to the change ticket. So you can see there I've mentioned the service profile name, the MAC address, and the use that NIC's for, whether it be for vMotion or for the distributed virtual switch and which fabric, because obviously when they're VMware administrators on the ESX console, all he'll see is a list of generic Ethernet interfaces with their MAC addresses, so it'll probably save him a bit of time as well if he's got that little cheat sheet to refer to, and as well as the SAN admin who can immediately see what's meant to be on SAN A, what's meant to be on SAN B, and plus then he can do the SAN config all ahead of time. And again, just cut and paste. So it just makes everyone's life a bit easier in this world of convergence when we're all breaking down the silos and working a lot closer with each other. And likewise, I'd tend to knock up a short diagram of how my fabric interconnects are connected into my SAN and how my SAN is connected into my storage array. So you can see this is a EMC VNX example with 2 storage processors. So you can see there the worldwide node names above these storage processors, and then the worldwide port names which are in yellow there. and that obviously pertains to which port they are. And having a little diagram like that in front of you when you're configuring your zoning and just confirming your paths is invaluable, and again just really speeds up troubleshooting. Okay, so that about concludes our video. Hope you've enjoyed it. Hope you found something worthwhile. As ever, any questions, just fire back in the comments and I'll do my best to get back to you on it. So, been a pleasure this past hour. So this is me, Colin Lynch, UCS Guru, signing out. And in the meantime, take care of that data center of yours. Take it easy.